Hello and welcome to. So under this particular topic, we're going to look at sets. Okay. So first things first, we need to define what a set is. So we're saying a set. This is a set by definition. A set is a well-defined. A set is well-defined collection of distinct objects. Okay. Considering the following sets. For example, when we have a set of numbers, okay, set of numbers, or when we have natural numbers, okay. So we're saying a set, okay, is a set. Sets is a collection of objects, okay, well-defined well-defined objects. For example, we have numbers, okay. We have symbols. You can have symbols or letters, okay, or even you can have books, okay. So basically we're saying set, this is just a collection, okay, of certain things. For example, numbers. Under numbers we've got even numbers, symbols. We've got different symbols in mathematics, letters, okay. We've got the alphabet, the consonants, and the like, okay. Now we look at set notations, okay. We're saying a set is usually described by a letter of the alphabet, okay, and the members of the set enclosed in brackets, okay. For example, if A is the set of all numbers from 1 to 9, that set is expressed as A equals to open bracket, the curled brackets, okay, 1, 2, 3, 4, 5, 6, 7, 8 up to 9, okay. So a set is represented by, for example, okay, denoted by a capital letter A, for example, here, okay. Then we have our curled what bracket, where we have 1, 2, 3, 4, 5, 6, 7, 8, and 9, okay. So basically this is what this is how we supposed to write a set, okay. It's supposed to have what curled brackets, okay. All right. So now we look at describing ways of describing a set, okay. So a set is described in any form of the following ways. The first one is by listing the members of the set. For example, when we have, for example, this could be set A, okay. So this could be set A, okay, where we have A, okay. I'll use the other board, sorry for that. All right. So we're saying by what listing, okay. By listing, okay, we have this set, okay, listing of members of a set, e.g. where we have 1, 2, 3, 4, 5. Okay, this is what by listing. Then the other one is by describing the set in words. Okay, we describe the set in words by saying this particular set is described as a set of the first 5 natural numbers. Okay, first 5 natural numbers. Okay, or the first 5 positive what integers. Okay, this is how we can describe this particular set in words. Okay, then we have naming of the set by letters, okay, of the alphabet. Okay, okay, like we represented a set. Okay, so set A is equals to odd numbers between 4 and 10. Okay, set A is equals to odd numbers between 4 and 10. Okay, so this is the other way. Then the last one is we use the set builder notation. Okay, where we're saying that if we're saying open the curly brackets, x is such that 1 is 1 is less or equal to x less or equal to 6. Okay, okay, where we're saying x is a member of integers, so meaning that x is an integer lying between 1 and 6 inclusive. Okay, thus a is such that 1 is less or equal to x less or equal to 6. Okay, and is a member of what? An integer. So basically the numbers are lying between what? 1 and 6. So it's 1, 2, 3, 4, 5 and what? 6. So this is how we can describe what? Sets. So we describe a set, as we have said, by listing. Okay, then using the set builder notation. Okay, then we describe the set by using words. Okay, so for example, we can list, okay, A is equals to let's say A, B, C, and D. Okay, this is listing. Okay, then we can also use the set builder notation. So as I showed you in that example, okay, and also we use by using words. For example, this is a set of what? Even numbers. Okay, all right, we proceed. So if you have got any questions, any clarifications where you are not here, let me know. All right, now we look at sets and symbols. Okay, so under sets there are some key symbols which we actually look at. Okay, so the first one is an empty set. So a set is said to be empty if it has no members. Okay, it's said to be empty if it has no members. If P is a set of whole numbers between 0 and 1, okay, between 0 and 1, then P is an empty set because there are no whole numbers between 0 and 1. Okay, so therefore so therefore the symbol for an empty set is these carry what? Brackets, okay, or this pitch symbol. Okay, so basically this is what we use when the set is empty, because the set has no elements. Okay, the set is empty. So when they tell you to describe an empty set, these are the two symbols you can actually use. Alright, now we look at the number of the number of members in a set. Okay, so we're saying a set is the letter n is used. Okay, the letter n is used for the number of members. Thus, if A is equals to ABCD, then A is equals to the number of elements. So we count A is equals to A, B, C, D. So the number of elements is 1, 2, 3, 4, and the number of elements of A is equals to what? 4. This notation of number of elements stands for the number of elements in set A, just as I have read. So I'll quickly show you an example. Okay, so we have a question there on the number of members in a set. Okay, so we're saying A is equals to 2, 4, 6, 8, 10. How many elements are in the set, in set A? Okay, so how many elements are in the set A? So number of elements in set A is how many? We have 1. Okay, let me use the other pen. Okay, so we have 1, okay, 2, 3, 4, 5. So the number of elements are 5. Okay, so the number of elements are 5. I believe it's clear on the number of elements in a set. So where you have any challenges, kindly let me know. Alright, now we look at an equal set. So we say sets are equal if they have the same members. Okay, so sets are equal if they have the same members. Okay, for example, if A is equals to 1, 2, 3 and B is equals to the first 4 natural numbers, then A is equals to B. Okay, because they have the same members. Okay, then if A is equals to ABC and I beg your pardon, if C is equals to A, B and D is equals to so equal sets, we're saying, for example, okay, if we have A is equals to 1, 2, 3, 4, okay, then set B is equals to 4, 3, 1 and 2. So what it simply means is that these elements, we have a 1 here, okay, we also have a 1 here, okay, we have a 2 here and we also have a 2 here. Okay, we have a 3 here, we also have a 3 there, we have a 4, and we also have a 4 here. Okay, so this is why we're saying A is equals to B. Okay, so the number, okay, the number of elements in A is equals to the number of elements in B, which is equals to 4. Okay, this is why we're saying they are equal, because they have got the same elements. Okay, then another example I can give you is where we have, if set C is equals to A, B, C, okay, and set D is equals to D, E, F. Okay, D, E, F. So are these sets equal? They are not equal because they don't have the same what? The same element. Okay, because when we are saying a set is equal, they need to have what? The same element. So we don't have an A in here, we don't have an A in the other equation. So in this sense, we are saying beg your pardon, let me just delete that. So we're saying C is not equal to D. Okay, why are we saying that C is not equals to D? Going back to our notes, we are saying sets are equal if they have the same members, okay, or same elements. They are only equal if they have the same members or elements. Like in this particular case, these they don't have what? The same elements. This is why C and D are not what? Equal. Okay, so please take note, the symbol for this is not equal to. Okay, then we have the symbol for equal, which I believe you all know. Okay, all right, we now look at subsets. Okay, so we're saying this is a set. This is a set which also belongs to another set. Okay, so what we're saying, a subset. Okay, I'll just draw a circle here, or so this is a set within a what? A set. Okay, for example, we've got A here, this is B. So what we are saying is A is a what? Subset of B, because all the elements which are found in A are also found in B. Okay, so this means that the symbol used is, which is a subset of this. Okay, so if V is equals to vowels and A is equals to A, so A is a subset of what? V, as I have explained here. Okay, then we have this principle which we use to say to find the subset of our elements. Okay, so the number of subsets of a set is 2 to the power n, where n is the number of elements. Okay, the number of elements in a set, e.g., a set with 3 elements has okay, so a set with 3 elements, for example, okay, so it's going to be 2 to the power n, okay, to the then 2 to the power 3, okay, this is just 3 times 3 times 3, which is equals to 8, okay, so which is equals to 8, which sums up to we're going to have how many subsets of this particular set? We're going to have 8. Okay, so we're going to have 8, okay, for this set, because it has got how many elements? 3. So there are 8 subsets. Okay, if A is equals to this, the subsets are A, okay, BC, that's the first one, then AB, okay, just like that as I have written, then AC, you put the curled bracket, then B comma C, you put the curled brackets, then A, we have B, then C, and we have what? An empty what? Set. So basically these are the number of subsets if we have got 3 elements according to this particular question. So we'll look at another question on how to answer this. I'll write it down. Okay, so I've been given this particular question where I say let A be equals to 1 and 2. List all the subsets of the set. Okay, so we know that our formula is 2 to the power n. Okay, so which is equals to what? 2 to the power the number of elements. So we know that n represents the number of what? Elements. Okay, so it's 2 to the power 2, which is just 2 multiplied by 2, which is equals to 4. Okay, so the number of subsets are just 4 what? Subsets. Okay, so we're going to have our answer solution. Okay, we're going to have a curled bracket which is empty, comma, okay, then we're going to have 1, okay, then we're going to have 2, and we're also going to have 1 and 2. Okay, so when we count this, it's 1, 2, 3, 4. So it has got how many subsets? 4. So basically this is how we answer questions on this particular on subsets. Okay, right, now we look at membership. So the symbol for membership is this symbol here. Okay, just like an E, although it's not E, and it's denoted by membership. Okay, so P is a member of B. This means that the elements of P is a member of elements of B. So if P is not a member of B, we write it as P is not a member of B. The symbol means P is not a member of what? B. So this is the symbols for membership. Okay, and not a member of. Okay, so we're saying we have the symbol for what? Member. Okay, this is member of. Then the other one is not a member of. Okay, so these are the two symbols under membership. Okay, I believe these are straightforward. Okay, now we look at the intersection of a set. So we're saying sets are said to be to intersect if they have members in common. Okay, for example, if A is equals to A, B, C, and D and E, okay, and B is equals to A, B, C, F, and H, and I. Okay, I'll quickly write that. Okay, so we're saying the intersection, the elements have to be common in both sets. So we are given an example here, okay, where we are saying we say A is equals to A, B, C, D, E. Okay, the B is equals to B, D, F, F, H, I. So what are the the elements which are common? We have what? B, and we also have B in here. Okay, then we have what? D. We also have D. Okay, so the two elements which are common. So A intersection. Okay, so this symbol means what? Intersection. Okay, so it's B and D. So this is how we are supposed to find what? The intersection. Okay, it's the two or the elements which are common in the number of sets which you have been given. Okay, right, we now look at the union of a set. Okay, so we're saying the union of two sets or more sets is assembled by the assembly of sets. Okay, assembling of sets. Okay, so when we talk about union, it's like you bring together all the elements which are found in all the sets. Okay, for example, if P is equals to these elements, I'll write them on the other part. Then P union B is going to be all the elements in the set. Okay, so the symbol we use is the symbol like Q, but it's not actually denotion of union. Okay, so on the other hand, let me write the question we solved. Right, so we're saying a union of a set. So a union of a set, this is a set of all the elements of the original set. Okay, it's all the elements of the original set. So in this particular case, we have been given this question. Okay, we have been told to find P union Q. So that's the symbol for union. Okay, so we are told to sorry for that. So we are told to find the union for P union Q. Okay, so we list all the elements in the two sets. Okay, but do not repeat those which are found in the two sets. So we have A B, C, D, E, F, G, H, I. So these are the elements, not I but H. Okay, so these are the elements which are found in P union Q. Okay, so this is how we find the union. So union, we are saying all the elements in the set. Okay, so all the elements in the set. Right, now we look at the universal set. Okay, so this is the set containing of all the elements under consideration. Okay, it is denoted by E. Okay, so for example, right, so the universal set, okay, it's symbolized by this particular symbol. Okay, so the universal set, it is actually contains all the elements. Okay, so when we are given our universal set as 1, 2, 3, 4, 5, and 6. Okay, then set A is equals to 1, 2. Okay, then set B is equals to what? 2 and 3. Okay, so our universal set, I'll draw our rectangular circle like this. Okay, so that you can understand what I'm talking about. Okay, so we have something like this. Sorry for it's not clearly written. So we have our universal in here. Okay, we have A, B. So what is common? What is the intersection in the two sets is 2. Okay, which is this one here. Okay, so 2 will be here. Then we have 1 in A. Okay, then we have 3, which is under B. Okay, then we have 4, 5, and what? 6. So the universal set, it is everything. All the elements are found in the universal set. So this is how we'll be drawing our Venn diagram, something like this. So the universal set, it shows all the elements in the set, because the universal, it is the whole thing. Okay, right, so we're saying this is contains all the elements under consideration and is denoted by that symbol I showed you. So example, if in a school, M represents mathematics teachers, P represents physics teachers, and G represents geography teachers. Then the universal set of the teachers is the teachers of the school, because it is talking about all the teachers in the school. Okay, so now we look at a complement. Okay, so a complement, okay, a complement, we're saying the complement of a set, okay, it is denoted by A with an apostrophe. Okay, the complement of set A is denoted by A with an apostrophe. This is a set of members of the universal set outside set A, or members of the universal set which are not a member of A. Okay? For example, so I'll translate this example, then I'll show you. So we're saying a complement of a set. This is a set of all elements which are not in that set, but they are in the universal set originally given. Okay, so for example, we have been given this example where we're saying our universal set, is equals to 1, 2, 3, 4, 5. Okay, so set A is equals to what? We have 3 and 5 as our set A. Okay, sorry for that. So this is supposed to be 3, 5. Okay, then we're saying find a what? Complement. Okay, so we're saying a complement. Okay, this is where we're saying a complement. This is a set of all elements of the original set. Okay, sorry, I beg your pardon. This is a set of all elements which are not in that set but are in the universal set originally given. So A complement. Okay, these are elements which are not in A. Okay, so excluding these elements, but they are found what? In the universal sets. So what are these elements? We have 1, 2, and 4. So these are not found in A. Okay, so basically this is how we are supposed to answer if we are given to find on complement. Okay, so they have told you not to select from A, but you can select from the universal set and the other sets. Okay, so there is an exercise for you to do here. Okay, you can do this exercise. Okay, it's a very simple exercise, so you can pause the video and try to work out this particular question, work on these questions. Okay, so make sure you pause the video, try as much as possible to answer these questions. Okay, alright, now we move on. We look at the Venn diagram. Okay, we look at Venn diagrams. Okay, so Venn diagrams are used to illustrate sets in a pictorial way. This is done by drawing a rectangular with circles in within the circle, within the rectangle, if the universal set is not defined. So the rectangle represents the universal set, okay, and the circles represent the sets of the universal set. So I'll briefly show you how to draw a Venn diagram. Right. So this is a question on Venn diagrams. We're saying the investor set is equals to A B C D. Okay. Then set B is equals to A B C. Okay. Illustrates the information, should be the information in the Venn diagram. Okay. Illustrate this in the Venn diagram. So we'll draw our circle, our rectangular something like this. Okay, so we have our E, our investor. Okay, then we have our B, set B. So set B has got A, B, and C. Okay, then outside we have D. So basically this is how we can draw our Venn diagram. This applies also to when you have got two circles or even more than two sets. Okay, two sets or more than, or three sets. Okay, right. So we now look at shading on the Venn diagram. Okay, so we have our first one there. Okay, where we have seen the universal set, then set A, set B. So this is the universal set. Okay, then look at the next one. Right, the next one is set A. Okay, set A. Right, set A. So this is diagram 1. Okay, then this is diagram 2. Okay, then we move on to diagram 3. Okay, so we have something like this. Okay, sorry for that. Where we have our investor, then we have A, B. Okay, then this part which is shaded is the what? It's A intersection B. Okay, so this is A intersection B. Okay, then we have the fourth one, which is we're going to have the inverse set. We have A, B. So everything in the two sets is shaded. Okay, so everything in the two sets there is shaded. So this is going to be A union B. where we said where where there is union of sets, all elements are shaded in those two sets. Okay, so this also applies where you are given three equations, or I mean three sets. Okay, you can do the same and you get the full marks if you are given such a question during the exam. Okay, right, so we have the union. Okay, right, then we have the last part where we have a complement. Okay, so which means we shade everything else except set A. Okay, so this is what A what complement. So this is supposed to be an apostrophe. Okay, so this is A what complement. So if you have got any questions on the shading where you are not clear, kindly let me know. Alright, we have been given this particular question. Okay, the Venn diagram shows below the illustration of set A and B. Okay, so we have 6 in set A, we have set A here. Okay, this is set A, this is set B. Okay, we have 6, 8, 2, 4, 7, 1, 5, and 3. Okay, so using the Venn diagram, write down so we're told to find A, the universal what? The universal list. Write down the universal set. So we're saying that for the universal set, it's all the elements found in the set. Okay? So in this particular scenario, okay, we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is the first question. Okay, then the next question says B says set A. Okay, set A so set A, so we look at our set. Okay, our set A has how many elements? It has got 2, 4, 6, and 8. So it's 2, 4, 6, and 8. Okay, then we move on to C. Set B. Okay, so set B has got 2, 4, 7, 1, 5. Okay, so it's 1, 2, 4, 5, 7. Okay, so we get from this particular region, which is 1, 2, 4, 5, and 7. So 1, 2, 4, 5, and 7. Okay. Alright, the next question says A union B. Okay, I beg your pardon, A intersection B. So what are the two elements which are found in A and B? Okay, so if we look at our Venn diagram here, we have two elements which are found in both sets that are intersecting. So it's just 2 and 4. Okay, 2 and 4. Okay, 2 and 4. Okay, we move on to the next question. Right, we move on to E. So it says A complement. This says A complement intersection B. So how can we answer this particular question? So first of all, we need to know elements which are not in A. Okay, so we write down elements which are not in A. Okay, so these elements which are not in A include 7, 1, 5, 3. Okay, so we're saying we have 1, 3, 5. Okay, and 7. Okay, then what is found in B? We check our B. We have 2, 4, 7, 1, 5. Okay, we have 1, 2, 4, 5, and 7. Okay, so this is what. So now from here we'll be able to tell what is found in both sets for us to find A complement intersection B. Okay, so how can we find this? We simply say we have a 1 here. Okay, we also have a 1 here. Okay, we have a 5 here. Okay, we also have a 5 here. Then we have a 7. Okay, we also have a 7 here. So basically we have found our what? Our intersection, okay, to be 1, 5, and 7. So this is how we find A complement intersection B. This is the easiest method. Okay, we move on to the next question. Alright, so the next question there says A union B. How do we find A union B? So all the elements which are found in the two sets. Okay, so we have 1, 2, 4, 5, 6, 7, and 8. Okay, so we have 1, 2, 4, 5, 6, 7, and what? 8. because they are found in the union of B and D, of A and D, A union B. Okay, we move on to the next question. So the next question there says find A union B complement. So A union B complement, which means excluding A union B. So the only element which is not found in A union B is 3. So our answer for this particular set is A union B complement is just 3. Sorry for that. Okay. Right. So that's our answer. Alright, so referring to our question on top there, so we have our A. It has got the following set A is equals to 2, 4, 6, 8. Okay, then A complement, B complement is basically just 3, 3 and 3 and 6. So and 8. Okay, so the number of elements that are intersecting is we have 6. This side we also have 6. Then we have 8. So they want the number of elements A intersection B complement. So it's 2. So our answer there is just 2. Then the last question. Okay, the last question we have been given as I number of elements in A intersection B complement. Okay, so we're referring to the numbers which are not found in A intersection B. So the number there is just 6. Okay, so this is how we're supposed to answer this particular question. Okay, thank you. We proceed to another question. Alright, in this particular question, okay, we are told to on the Venn diagram shade the region. The first one is X complement intersection open bracket Y intersect W. So we're excluding X. Okay, and we are told to focus on this part. Okay, so intersection of Y intersection W. So the region we're going to shade is just this part. Okay, so this is the region we're supposed to shade for this particular question. Alright, we have been given another question. We're told to say x intersection y, okay, union w. So when we are told to shade x intersection y, okay, we simply shade this particular region, the intersection of okay, then we are told to shade union w. So all elements of w we are supposed to shade. Okay, so this is how we are supposed to answer this particular question. Okay, so we move on to the next part. So in this particular question, we are told to find y in the diagram, okay, in the Venn diagram, okay, in the given diagram, if the number of elements in A union B is equals to 27. The number of elements are shown. Okay, so how can we find y? So we are told to say y plus, so we're going to add y plus 6 plus 14 is equals to what? 27. Since we know the union of the whole set is equals to what? 7. So we're going to equate it to 27. Okay, so plus 6 plus 14 equals 27. Okay, so when we add up 6 plus 14, we get 20. Okay, this is equals to what? 27. Okay, so what's going to happen is this will cross the equal sign, then we're going to have 27 minus 20. Okay, then when we subtract 27 minus 20, we get 7. So our answer is just going to be y. It's going to be equals to 7. So y is equals to 7. Right, we move on to our last question, okay, under this particular topic. Okay, so if E, or the universal set for all numbers from 1 to 15, okay, so the universal set E is equals to the universal set is equals to all numbers from 1 to 15. Then set A is equals to even numbers between 1 and 15. Then B is equals to multiples of 3 between 1 and 15. Okay, then C is equals to 6 and 9, 7, 9 and 10. Lists set A and B and state the elements of A union B. A intersection B, then A union C. This is supposed to be C, beg your pardon. Then B union C, and beg your pardon, D intersection C, and A intersection B intersection C. Show the sets A, B, C, and the Venn diagram. So basically what we can do for this particular question is, first things first, we need to know the universal set. Okay, so our universal set, okay, we are told all numbers between 1 and 15. So 1 and 15, so it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, so this is what is under this particular set. Okay, so now we are told to list set A. Okay, so we are told even numbers between 1 and 15. So even number, an even number, this is a number which is divisible by 2. So we have 2, 4, 2, 4, 6, 8, 10, 12, and 14. Okay. Then we are told to list B, set B. So set B is we are told to list set B, which is the multiple of 3. Okay, from between 1 and 15. So we have 3, 6, 9, and 12. Okay. Okay. Then we know that set C is just 6, 7, 9, and 10. Okay. So now we are told to find A. Okay. So in A we are told to find A intersection B. Okay. So what is common in A and B is we have 6 here, so we have 6, we have 12, we also have 12, so it's 6 and 12. Okay. Then B, we are told to find A intersection C. Okay. So what is common in A intersection C? So we have 6, and also there is a 6 here. Then we have 10, and also there is a 10 here. So it's 6 and 10. Okay. Then we are told to find C. Okay. B intersection C. B intersection C. So what's common between B and C? Where there is a 6. Okay. Then also we have sorry. So what is common is in these two sets is 6 and 9. Okay, 6 and 9. Okay. Then we are told to find A intersection B intersection C. So what is common among the three sets? Okay, so we have 3, 6. It is found in set C. We also have 6 here. We also have 6 there. So what is intersecting in the three sets is what? 6. Okay. From here now, we can plot our graph. Okay. Alright, so we replace what we know already. What is intersecting in both sets is in the three sets is 6. Okay. Then what is found, what is intersecting in A and in B is we have 12 there. Okay. Then what is intersecting in A intersection C? This is 10. Okay. Then A intersection C is just 9. Okay. So then here we're going to have 3. Okay. We're going to have 7. Then we're going to have 2, 14, 4, 8. Then in the inverse set we're going to have 11, 13, we're going to have 15, we're going to have 5 and 1. So this is how we have illustrated this work on the Venn diagram. Okay, thank you. Just want to emphasize one point which I left out before the end of this particular topic. Alright, so the other thing I wanted to talk about is the infinity and infinity set. So when you talk about the infinity set, this is a set. Infinity set is a set of which contains a limited number of elements. Okay, it contains a limited number of elements. Then an infinity set is a set which contains an unlimited number of elements. It's uncountable. Okay, so infinity test set, this is countable. Okay, so basically this is what I wanted to emphasize. So we have come to the end of our lesson on this particular topic, sets. Okay, so where you have questions, where you have clarification, kindly ask through the platform. I'll be able to respond. Thank you very much. This has been your online tutor, Mr. Ilaki.